Welcome to Module 3, where we're working on division. This isn't really a lesson necessarily that goes along with one of our problem sets. This is just a way for us to be practicing a division strategy. So in this case, we're going to be practicing partial quotients. But to kind of recall back on our knowledge of using the area model for division, because it's so closely related to partial quotients, we're going to do a couple practice problems to recall on that knowledge from before. So go ahead and work along with me. If you want to solve and then pause and check once you're done, that's absolutely a good way to approach this. If not, you just want to see a problem and then practice a problem afterwards, you can also do that as well. But this first problem we're going to start with is 89 divided by 5. So I know that this sign right here looks a little bit different than what you probably are used to seeing, but in the case of having the keyboard, it also means that sign right there. So you might see this every once in a while if I don't have the ability to put a division sign on there, but also just know that that's the same thing as having 89 divided by 5 under our bracket. Those are all equal to one another. Okay. Now when we're doing division with an area model, our goal is to be taking chunks away. We want to get this dividend, that number that we are dividing up, we want to break it up into as many groups of 5 as we can. But we're going to be getting to numbers where you're not going to know a math fact right off the top of your head that's going to get you to that number with a remainder, maybe without a remainder. So we want to work on strategies that are going to get us to that final quotient. And in doing that, one of those ways is doing this with the area model. So in this case, one of the first things I really like to do is jot down some of those heavy hitters. And again, heavy hitters are those numbers that they're kind of like a menu of chunks that I can pull from so that I can start subtracting it from my large number of 89. So in this case, your heavy hitters have got to be multiples of whatever number you're dividing by, this divisor. So when I say multiples, I mean it's like if I were skip counting by this number, I would reach these answers. So in this case, I might think about doing 5 times 1, 5 times 2, 5 times 3. Now, of course, these are not the only ones that you can do. These are typically the way that I like to just kind of start myself off. But if you know some higher 5 facts that would be helpful to you, maybe you want to go ahead and skip to like 5 times 9. Then go ahead and do that. I also like to, once I get those first couple, then I start to do like the multiples of 10 here. So 5 times 10. 5 times 20. Because if I know what 5 times 2 is, then I can figure out 5 times 20. 5 times 30. So if I go through and answer these here, okay. So like I said, I'm kind of just creating like a bank of numbers that I can pull from. But again, they're not the only numbers that I can be thinking about as I go to subtract or take chunks away from. Okay. So in this case, I'm looking for a number that's going to take away one of the biggest chunks I can get. Because the thing is the bigger chunks you take away, the less work you're going to end up doing in the end. You won't have like little problems that you'll be solving. So I'm going to start with my area model here. I'm dividing by 5. So every number that's up top here, if I multiply that by 5, it's going to get me the number inside my box. Just like if I were doing area model for a multiplication problem. And then my chunk, or my number that I'm going to start taking chunks from, is 89. That's where I'm starting. So if I look here at my heavy hitters list, well, right now, this one's not going to be helpful to me, and this one's not going to be helpful to me. And I'm hoping that you're thinking to yourself, well, those aren't going to work because the product's too big. I can't take 100 away from 89 because I don't have enough. So I'm just going to get rid of those. I don't even need them. In this case, I'm seeing from what I have listed that 50 is probably my best option. So your goal is, like I said, not to try to get as close to to try to get that exact number of 5 times something gets me closest to 89. You don't have to do that, because in the end you'll probably actually end up doing more work than if you just start piecing away at it. So in this case, I know that 5 times 10 is 50, I'm sorry. 5 times 10 is 50. So actually, you know what I'm going to do? I'm going to change my color here. So 5 times 10 is 50. Okay, now I'm going to take my chunk away. I'm going to make that number smaller. So when I subtract, 9 minus 0 is 9, 8 minus 5 is 3. So now my number, I've made 10 groups out of my 89. Okay, now I have 39 left. So I've got to, at this point, make another box to my area model and send my 39 over. The reason that we're making another box is so that we can keep our work organized, where it's not a big jumbled mess of subtraction problems. And it lets you know, okay, I'm now making another chunk. I'm removing another chunk. Okay, so looking at my numbers over here in my heavy hitters list, well, 45 is not going to really help me right now. 50 is not really going to help me right now. So I'm going to stick with 15. That's a pretty easy one for me. So actually, I'm thinking 5 times 3 is 15, but I know that 5 times 6 is going to get me even closer. 5 times 6 is 30. So if I take 5 and I multiply it by 6, I know that that equals 30. So my next chunk I'm going to take away is 30. So I subtract. 9 minus 0 is 9. 3 minus 3 is 0. Okay, so I've taken now 6 more groups of 5 away from the 89. Okay, I've got a remainder still. It's bigger than my divisor, so I've got to keep going. I've got to keep going until that remainder is smaller than my divisor. So I bring my 9 up, bring it over to my next column. Okay, now I'm thinking, okay, what do I have here? How many times can I divide 5 into 9? How many groups of 5 can I get from 9? Well, if I look over here in my heavy hitters list, I have 5, I think, is going to be my best option here, because 10's not going to work, 15's not going to work, they're too big. So if I make one group of 5, 5 times 1 is 5. So I'm going to take one group of 5 away from 9, and when I subtract, I get 4. Now, I know that I'm done because this 4 is smaller than my 5. I cannot get another group of 5 out of my 4. It's not big enough. So I know that I've finished my problem here, and I've got, so this becomes my remainder, and my quotient I have to find up here at the top. So I've got to make sure I add those numbers together. However many there are up there, you should have one number for each section of your area model. I've got to add those together. So I have 10 plus 6 plus 1. Well, I know 6 and 1 are 7. So I have 17 with a remainder of 4. And I got that from right there. Now if I want to check this, I've got to take my quotient, so 17, and I'm going to do the opposite of division, so I'm going to multiply by the number I was dividing by originally. 5 times 7 is 35. 5 times 10 is 50. So I get 85 with a remainder of 4, so I've got to add that 4, and I get 89. Sorry, I was kind of creeping off the paper there, but I've got 89, which tells me that I've done this correctly, because notice 89 was what I started with under the bracket. Okay, we're going to switch screens here. We're going to look at a problem that's a little bit bigger, because this is where we're kind of heading, is we're going to go all the way up to 4 digits, but I want to show you kind of this process with the area model, just with a larger number, because really the process is the same. You just have a bigger number that you're trying to take away from. So in this case, again, I've got my symbol that looks kind of weird, but this really is 678 divided by 4 is what that means. Okay, and I'm going to start with my heavy hitters over here. So those chunks that I can be taking out. So I've got to do multiples of 4 here. So I might do 4 times, in this case, I've got a number in the hundreds, so I'm going to beef my numbers up just to start. So I'm going to start with 4 times 10. And go ahead and do 4 times 20. 4 times 30, because I know that if I start, I could do my 4 facts pretty quickly off the top of my head, but it's these other ones that are going to give me a good visual of larger numbers that I can be pulling from, because if I just pull single digits, it's going to take me forever to do 678. And now I'm going to step up my game, and I'm going to go not just times 10, but times 100. 4 times 200 is 800. I'm going to stop there though, because I know that 800 is too big, so I won't even be able to use that really. So I'm going to stop there. And if I need to add heavy hitters on later on, I can always do that. But this is, I think we'll start, and then if we need to do that, we can revisit. So I know that I'm dividing by 4. And I know that I'm starting with 678. That's what I'm trying to find. How many groups of 4 can I make out of 678? So if I look at my heavy hitters here, I'm really liking this 400 number. That is a really good chunk that I can take away. Well, I know that 4 times 100 gives me 400. So I'm going to take that chunk out, and I'm going to see what I've got left afterwards. So I've got 8, 7, 2. Whew, that reduced my number quite a bit. That's exactly what I'm looking for. Okay, that's my remainder, so I've got to move it over to my next column. So send it over, 278. Okay, now I'm looking for my next chunk that I can take out here. So if I'm looking at my heavy hitters list, 400 is not going to work anymore, but I am liking this 120. So let's see, 4 times 30 equals 120. And remember, that's the chunk I'm taking out. So I am subtracting. I can make 30 groups of 4 with 120. So when I subtract, I'm left with 158. Well, that remainder is way too big still. But I do notice that I can take another group of 120 out. So that's what I think I'm going to do. I'm going to make another box. I'm going to move my 158 up, because that's my remainder. And then I'm going to do 4 times 30 again, which gives me 120. And subtract 8, 3. So, I'm down to 38. Okay. Well, I've still got too big of a remainder, so I've got to add another column. And you can just keep adding columns until you get to the bottom of your problem. However, like I said, the bigger chunks you take out, the less columns you're going to have. So typically about 2 to 3, maybe 4 columns, like in this case as our numbers get bigger. That's about appropriate. If you end up with 8 or 9 or 10 columns, then your chunks that you're taking out are not big enough. Okay, so I have 38. Well, none of these are going to be helpful to me, so I'm just going to think of 4 facts right now that are going to be beneficial. So I know, let's see, 4 times 10 I know is 40. That's super close. So what about 4 times 9? Well, if I take 4 away from 40, I have one less group of 4. That's going to give me 36. Ooh, that gets me super close to 38 without going over. So let's do this. I'm going to bring my 38 up, because that's what's left over, and that's what I'm trying to chunk away from again. And I'm going to subtract 36. Now what I don't want to forget is, how did I get that 36? Well, I said 4 times 9 gave me that 36. I want to keep track of that. And when I subtract, I have a remainder of 2. Now I know I can't go any farther because my remainder is smaller than my divisor, which is what I'm looking for. So in this case, I have a remainder of 2, and I'm looking for my quotient. So I'm looking at these numbers up top, and I'm going to add them. So I've got 100 plus 30 plus 30 plus 9. So 9, 6, and 1, with a remainder of 2. Now, if I want to check this, I'm going to take that quotient, so 169, times my divisor, the number that I divided by, and 9 times 4 is 36. 4 times 6 is 24. 25 times 6 is 27. When I add that 3 on, carry my 2. 4 times 1 is 4. 5, 6. So I got 676, but I can't forget my remainder. I've got to add that on, so remainder of 2, and I end up with 678, which matches again that original dividend, which tells me I've done my problem correctly. All right, we're going to be looking now at the partial quotients part of this. Now, partial quotients is very similar to area model. It's basically the same with the exception of there's not a picture that goes along with it. So in this case, I'm going to rewrite my problem, 57 divided by 4. Now when you do partial quotients, and I want you to work this problem along with me, when you do partial quotients, I want you to make your bracket, I want you to extend that side down, and you're going to end up making a box over here. And I'll explain why here in just a second. But what we kind of call this sometimes is people think of it like a faucet because it looks kind of like the thing that your water comes out of as kind of a way to help them remember how to set this up. So partial quotients means basically we're going to be taking parts away to find our final quotient. So just kind of like when we did partial quotients with multiplication, we were kind of chunking away at our final product. So in this case, you're going to do a very similar process of thinking about what are some heavy hitters that I can use to start chunking away from 57. Okay, so in this case, I need multiples of 4 because that's the number I'm dividing by. And let's see, I'm going to do 4 times 2. 4 times 3. I'm not going to go too crazy because my number that I'm dividing up, 57, is not all that big. Maybe you'd do a 4 times 10, 4 times 11. So let's see, I've got 8, 12, 40, and 44. Okay, I think that'll be good right now. Again, if you have other problems or facts that you can think of, it doesn't have to be a specific fact that you write down for those heavy hitters. It can be others. Those are just kind of ones that I'm thinking about right now. So when we do this, you're saying to yourself, okay, what chunk am I going to take away? So in this case, I see 44 as being a pretty big chunk that I can subtract. So I'm thinking 4 times 11 gives me 44. And I'm just like in the area model, I'm going to go ahead and subtract. So when I subtract 57 minus 44, I get 13 remaining. Well, that remainder is too big right now. So again, I've got to chunk and take away. So in this case, I'm looking at my heavy hitters over here. Do I have something close? I can use 12, and that's what I would highly recommend. I'm going to show you if I didn't think of 12 and I may be thinking of 8 instead, I'm going to show you with 8. But I would probably use 12 in this case because it's one less step that I have to do. Okay, now I'm thinking, what chunk am I going to take away from 13? Well, I'm going to take 8 away, and I got the 8 by saying times 2. 4 times 2 equals 8. Then I'm going to subtract, try to get that dividend down as small as I can get it. 13 minus 8 is 5. Okay. Then I ask myself, can I get another group of 4 out of this number? Well, if I think about this just visually, and I have a group of 5 ones, well, I know that I can get a group of 4 out because if I think about an array model, my goal was to group them together. And I can get one more group out of it. And I know that 4 times 1 equals 4, which is going to get me that last group. And when I subtract, I get a remainder of 1, which I know must be my final remainder because it's smaller than 4. So the really cool thing about this is now I know here's my remainder, and to find my quotient, this is why we've got this box over here, is now I can take these numbers that I've kind of collected along the way, and just like with the area model, these would be numbers that you saw above the area model. I'm going to add them up. So I have 2 plus 1 is 3, plus 11 is 14, with a remainder of 1. And if I want to check this, I'd say, okay, 14, my quotient, times 4 is, 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5, with a remainder of 1. And I get 57, my original dividend. So I know that I've completed this correctly. So this is where kind of transitioning from that area model is going to be helpful because it's really a similar practice. It's just you're not so much drawing those boxes in that visual that you had before. It's more so like a math equation that you're thinking about. So let's try this again. We're going to do another problem. We're going to do a little bit bigger problem because again it's same process, but we want to start thinking about greater numbers here. So in this case, I've already got my bracket set up. I am going to go ahead and add my extra box though, so that I can keep I like to keep my quotients separate from the other numbers so that I don't have to hunt them down later on. And I'm going to go ahead and write my problem in. So I have 453 divided by 3. Okay, so my problem's set up. My next step is I'm going to come up with some heavy hitters. Now again, keep in mind you are now dividing a number in the hundreds. So you're probably going to want to come up with facts that are a little bit greater here. So in this case, I typically like to kind of start with the tens and then maybe move into the hundreds. So 20 times 30. Okay, and then we've got 30, 60, 90. Okay, those are pretty good. Let's try 3 times 100. That's 300. 3 times 200, that's going to give me 600. So I'm not even going to write that one down because I know that that's too big. I can't take a chunk of 600 away. So let me see. Let me do like maybe a 3 times, let's do 3 times 50. That's a pretty easy one. 3 times 5 is 15, times 10 is 150. Okay, I'm going to start there. Again, I can add later on, but here's where I'm going to get myself kind of in the zone and started with. Okay, so I'm looking for a number that I can chunk away from 453. In this case, I'm seeing this 300 looks really nice to me right now. And I'm thinking, okay, I'm taking a chunk of 300 away. And I can make 100 groups with that. So 3 times 100 is 300. And I've got to subtract to find out what is remaining, because I know I need more than 100 groups of 3, because I'm going to have some left over. So in this case, I have 153 as a remainder. Too big. I need to take more groups of 3 away. So if I'm thinking about this now, I'm thinking about, okay, what's a new chunk that I can take away? Well, I'm noticing I have 150 right here. That's super close. So if I think about 150, well, that's what I'm going to chunk away. And to get that 150, I have to multiply by 50. 3 times 50 is 150. Okay, so I just took 50 more groups of 3 away, and I ended up with 3 remaining. So I have 3 as a remainder. Well, here's where this can be kind of confusing, or that people might kind of look over, is that remainder of 3, you've got to think to yourself, can I get another group of 3 out of that? And because your remainder is equal to the number you're dividing by, the answer is always yes. Because if they are equal, that means that I can get one more group out of it. So in this case, my group is going to be a group of 3. And I got that group of 3 by saying, okay, 3 times 1 is 3. And when I subtract, I end up with nothing as a remainder. So my final quotient, here's my remainder, 0. My final quotient, remember, I'm going to take those partial quotients, those part quotients that I've gathered, and I'm going to add them up now and get my final. So 100 plus 50 is 150, plus 1 is 151. So if I were to take 151 times 3, I should get 453. So 3 times 1 is 3, 3 times 5 is 15, carry the 1, 3 times 1 is 3, plus 1 is 4. And look at that. I did get, in fact, 453. This last problem that I'm going to complete, I'm going to have you pause here in just a second, and I'm going to solve out this problem, and then I want you to check. Once you finish solving on your whiteboard, I want you to come back and I want you to check along with me. See, do you have the same quotient? Do you have the same remainder? Now, your partial quotients, those numbers that we list off to the side in our box, may not be the same as mine because you may be thinking of different facts that I didn't think of, and that's okay. The important thing to remember is that you should have the same answer as me, no matter how you've broken the chunks up. So at this time, I want you to pause, because as soon as you play your video again, my answer is going to pop up on the screen. So pause, and then come back in just a few minutes. Alright, looking at my work here, I came up with a quotient of 84 with a remainder of 1. And just kind of a quick rundown of how I got that. I listed my heavy hitters over here. I decided not to go times 100 because the lowest one I could get, 4 times 100, would give me a number already greater than my dividend, so I just didn't even bother doing that. But I found 160, which, if you notice, I went ahead and I subtracted that twice. So I did times, I found one group of 40 and then I found another group of 40. So that's also a way that you can be thinking about if you have one that's consistently good with you're able to take that chunk away, then do it. So I took 160 away 2 different times, and then I figured out that 4 times 4, I could take a group of 4 away, and that would mean I took 16, and it left me with a remainder of 1. And then when I added those quotients, those partial quotients up, 40 plus 40 plus 4, I got 84, and then checked my answer here in the middle, and it checked out. So if you did not get a quotient of 84 with the remainder of 1, go back and check your work. Now, it could be that you maybe got the math fact wrong. It could be that you made a subtraction error. Those are the most common mistakes that you can make with this. So go back and double check those, because again, there's not a right way to start taking chunks away. It's, are you taking it all of the chunks away possible? Are you taking all of the groups out of 337? And in this case, it took 84 groups of 4 to get 337. So are you proficiently solving for those groups? And if not, where are we making those silly mistakes? So we're going to keep working on this, but this is just kind of a good preview of where we're going to be at for the next couple of days before we move on to our final strategy. Good luck.